Hey there everyone, my name is Rick Beddoe and you are in the Steam Factory lab at the moment. I figured I would maybe take a moment to take some time here to put a little video together. I'm going to give you a little backstory about Steam Factory, kind of where it all came from, how we got started. I'm also going to cover a use case, actually a really good one regarding additive manufacturing and how we really changed the life of this customer because of the terrific things we were able to do with additive manufacturing on this product. So yeah, that's what this video is going to be. Just kind of free association with this, but anyway, yeah. So let's begin with the story of Steam Factory and how this all kind of got started. Just a little background. My background is pretty varied. You can go on LinkedIn and see all the deets, but basically I've been in a broad sense, I've been in technology most of my career, and by technology I mean anything from software development, building computers, applications engineering, enterprise architecture, integrations. I went to school for industrial engineering and got my degree at Dunwoody. I've got a BSIE, Bachelor of Science in Industrial Engineering, which is a pretty broad category, but that combined with my background in design and mechanical engineering, I've been able to help a lot of people with who are looking for mechanical engineering assistance. I've worked for all kinds of companies in a design capacity, most recently a company in the Twin Cities here as a senior mechanical engineer for medical device manufacturing. So pretty varied background, but that's just kind of the foundation of what came next with Steam Factory. So I would say that yeah, Steam Factory is probably the most successful venture. I've had several, including a sign shop, an auto parts kind of thing back when I was a teenager. I've done computer consulting and all kinds of other sort of side hustles, startups, whatever you want to call them. My interest in 3D printing and additive manufacturing goes pretty far back. The first time that I saw anything with 3D printing was probably 1990 or 91. We had a field trip for a company called ADC. Back then, ADC Telecommunications, they made a lot of telecommunications components, connectors, brackets, all kinds of little devices, and they had one of the first 3D systems SLA machines, and we got to take a tour of their facility. They fired up the machine and showed us a part that they were printing, and we all kind of stood there and watched as the as the print started. And those old machines, those old SLA machines, were basically a vat of resin, and with a laser that was above the resin, and the build platform was kind of underneath the top of the resin. So the way that worked, it basically shined the laser onto the resin at the allotted frequency for or wavelength for hardening the resin, and it would do that in the shape of whatever layer it was printing, and then the build platform would lower for each subsequent layer. So I remember we were standing around watching it, and nothing appeared to be happening. And the guy said, "Just wait, just give it a couple more minutes." after about 5 or 6 minutes, we started to see a little part form in the liquid, and I'll never forget that. That just kind of blew me away when I saw that. So that was my first exposure to 3D printing. Years later, I worked as an applications engineer for a SolidWorks reseller and a company called Alinex, which then here recently became part of Go Engineer. But one of their customers was Stratasys, and everybody knows who Stratasys is. Stratasys started here in Minnesota, so we were fortunate to have those guys in for training when they purchased SolidWorks from us. And I actually had one of those guys print a model of my. I'm a sailor, and I have a 34-foot sailboat, and which I had modeled in CAD, and gave them the model, and they printed it. So and when I saw that again, just my mind was blown. The fact that I could get something that I designed as a 3D printed part. Now, that was the early days of Stratasys FDM printing. I think they said that print took maybe 2 days or something like that. It was a fairly large model. I'm not sure what machine they printed it on. I still have it, but yeah, the layers and all the things that we're used to with FDM, that was apparent. So it was pretty neat to see that. So that was Stratasys, and that was probably, I would say, 2004, sometime around then. And then after leaving Alinex and kind of going off in another direction, I started getting into software development and doing more kind of enterprise work. I was still doing design work kind of as a side hustle on the side, and I had this idea for a device. What I wanted to do was, if you're familiar with the goggles, the really inexpensive goggles, safety goggles that you put, and they kind of go over your eyes. If I wear those, they tend to fog up, and no matter what I put on them, defogger or whatever, they tend to fog up. So what I had an idea for was to put little fans in the tops where the vent was, and just little, I think they were maybe 15 millimeter fans. And I wanted to design a bracket to hold the fans, and so I designed the bracket, but then I thought, well, I'd really like to get one of these made, but I didn't want to pay the thousands of dollars for injection molding, right? Who does? So I thought, there were those Stratasys guys. I wonder how 3D printing has progressed. And this, I would say, this was probably 2010, maybe 2009. So I started looking into it, and I just Googled cheapest 3D printer, and the printer that came up was by a company called QUBD, and they had a printer on Amazon that was made from laser cut particle board, just little like 3/16 or maybe 1/4 inch thick particle board, and it was a kit. So you get the kit, and then you put all this together, and you have a 3D printer. Of course, didn't know anything about 3D printing or how to print or how to set it up, and it was the early days of what's called RepRap. Maybe I'll put a link in here to what a RepRap printer is, but suffice it to say, it was pretty janky, and but I didn't give up. I kept going with this printer and trying to get it to work, and then finally I had it all. I don't know what I did. I finally had it set up, and I was able to print a little 10 millimeter cube. So that's my very first print. That was great. So that would put me in the right direction, and from that point on, I was able to get the machine to print parts, and it was just a little tiny FFF printer. but I was hooked. And I did manage to print my little prototype, but that kind of went by the wayside, and I just became obsessed with 3D printing. And what I did with that machine was I kept printing more parts to make that machine better. And over time, I just had more and more parts, making it better and better. Eventually, there was just nothing left of that original machine. All the parts had been 3D printed. So then I had the great idea of saying, hey, if I can make one of these, and I 3D printed most of the parts, why don't I just make a second one? So I made a second machine, and then a third. And then I took that idea and created a little project that I called Protoplastic, and that turned into an open source set of models for 3D printed 3D printers, and that open source repository is available on GitHub, and I'll put a link to that in here as well. So you can download the STL files and you can build that. It's been a while since I've done anything with that repository. I still have some of the machines, and at one point I had 20 filling up my basement. I actually also put on a few classes for people to build the machines. I think we probably built maybe 40 to 50 machines during the course of the class. The machines have worked out really well. I'm kind of surprised. It's really amazing to think that I went from that to these machines. So I learned a lot from that. I learned everything that I know now about mechatronics, including stepper motors and drivers and firmware and all that good stuff. And then that kind of obsession grew substantially, and I was printing everything from more printers to drones to parts to you name it, all kinds of things. And it's about that time that I landed a job at a medical device manufacturer in the Twin Cities here, and became a mechanical engineer for them. They had Stratasys equipment on site, as well as some resin printers. I don't remember the name, but they were junk. They were really bad. So I came on board, and when I started, my manager was very generous, and we had a budget of about $50,000 to spend on some additive equipment, and that's when we bought our first Formlabs equipment. We bought 3 Formlabs Form 2s, and we're just kind of blown away with how cool they were and how reliable compared to other machines. These things were great, and the print quality was fantastic. The selection of materials were just great, and so we got a lot of experience with the Form 2s, and then the Form 3 came out. We picked up the Form 3s. We had 3 Form 3s as well. The Form 2s had kind of run their course and were long in the tooth, so we gave those away. We also picked up one of the first Formlabs Fuse 1s in the Twin Cities, so we were kind of an early adopter there. There were some things that we had to kind of work through. It was a little buggy, kind of not quite as buggy as the Stratasys F370 that we were also one of the early adopters of that machine. Then we had a Stratasys 450. We had Ultimaker S5 and a Markforged Onyx. So that's the Markforged that does not have the Kevlar or the filament that can reinforce the print. So we had quite a variety of equipment, but by far my favorites were the Formlabs Form 3s, just because the print quality and the materials were just phenomenal. And not without challenges. The Form 3s were were pretty unique in the way that they printed. They had the build tank, or the resin tank. And if you're not familiar with the way SLA works, SLA, when I say resin printers, Formlab resin, I'm referring to SLA. The basic operation is that you have a tank with some resin in it. There's a light underneath that shines into the resin, into the shape that you want, at the wavelength of light that hardens the resin. And it, again, subsequent layers are exposed. There's a build platform that goes into the resin tank and sort of picks up that image and pulls it up out of the tank. Now, in order for that to work, the platform has to peel it off of the tank. So there is an aspect of SLA printing called peel force, and in the Form 2 with a rigid tank, the peel force was pretty significant. So it did require quite a bit, and during that peeling of the print from the tank is where failures could occur. So Formlabs came up with a very ingenious idea to make the bottom of the tank flexible. So what that meant was the peel force for the platform was much less, because that tank could actually peel, could actually kind of roll, and as it rolled, it kind of peeled the image off the bottom of the tank and onto the build platform. So thanks to that low force, that reduced the failures quite a bit. Now, didn't reduce the failures down to zero, and I'll talk about that in a second. But needless to say, it was pretty cool. Kind of a little bit on the Rube Goldberg scale, because there's a lot going on. The imaging head, which is called the LPU, unlike on the Form 2, the imaging head actually moved back and forth, and that's what helped provide that peeling of the bottom of the tank. So you had all these moving parts, and you had a lot of, because the tank was flexible, if you had a high volume, the tanks could wear out. So it was there was a lot going on with the Form 3, but hands down, just one of the best resin printers on the market at the time. In fact, some of the Amazon special, China special, whatever you want to call them, the Elegoo's and Saturns or whatever, got wind of that and started to develop their own printers, and at a significant price reduction, but you get what you paid for. Those printers typically use an LED or an LCD screen, and it didn't have the ability to print at the quality level that the Form 3 could achieve. In addition to the Form 3, the Form 3L came out, and those two machines were kind of the primary resin printers for Formlabs for quite a while. And at that time, I had already started had already started Steam Factory. I had purchased two Form 3s for my own use for Steam Factory, and I was printing some parts here and there, until I came across a guy named John Music. And that was the beginning of a pretty significant chapter in the life of Steam Factory. All right, so who is John Music? John Music approached me on Facebook after he had talked to a former associate of mine. He had asked her if she knew anyone who did any 3D printing, and she just happened to know that I was doing some 3D printing, and I'd been involved in 3D printing for quite a while. So she mentioned it to him, and he reached out. I didn't think much of it at first. He just basically said, "Hey, we've got something we'd like you to try printing, and let us know what you think about it, and we'll talk more." So he sent me this device. Here it is right here. I'll talk more about what this is, because this is a game changer for us. He sent that device to me, and he said, hey, look, we've got these devices, and they go out to our employees, still not knowing what the company was or what this device was for. And years ago, we bought a container of these devices, a truck trailer container. So we had hundreds and hundreds of these devices, and now we're running out. We're running low, and we went to try to find the manufacturer. They're not around anymore. We contacted someone in China to see what they would want to basically re-engineer and develop this for us, and it was the cost was in the hundreds of thousands of dollars, because they wanted they'd have to develop it, and then they wanted them to commit to a certain amount of product. So he asked if I could 3D print that, and I said, well, do you have a 3D model? And he's like, no, we don't have anything like that. So I'm like, okay, well, here's what we'll have to do. We're going to have to reverse engineer this, and before we can even print it, in order to get a model. So so we took this. I was pretty excited. By this time, once we decided to work with him, he had told me who the company is. The name of the company is called VRAD, Virtual Radiologists. VRAD is a company that it's basically hundreds of radiologists working virtually for this company all across the country, and they use this device specifically to run the software that Virtual Radiologist has developed for analyzing CT scans, MRI, that sort of thing. The radiologists had the option to pick a different device. You can kind of tell from this, and I'll talk a little bit more about this. It's got buttons. It kind of goes like this. It's conform. It's actually a very, very comfortable device. There's buttons on the side here. There's 10 buttons altogether, and utilizing this to drive the software, radiologists have. It's a much easier way to do this than to try to use like a keyboard or the mouse. As I mentioned, they had the option to pick some other device. That was kind of a gaming device. They did kind of a shootout, had these at a conference next to these other devices, and they still picked these. They still preferred these over those devices. So Virtual Radiologist was kind of stuck, because the radiologists are their bread and butter. So what they say goes. They basically will do what the radiologists require. So we had to. I acquired a 3D scanner. That was not an expensive purchase. It was a mid-range, high-definition 3D scanner, and that 3D scanner basically. I learned about 3D scanning from that. 3D. If you're familiar with 3D scanners, you know that 3D scan is going to be kind of a raw format. It's not something that is easy to manipulate. So going from there to CAD was a pretty crucial step. I found a piece of software, I can't remember the name of it, that I bought. I got a trial version, and the trial lasted just long enough for me to use that to convert the scan into a CAD model that I could then use to produce to create the 3D print. Now, the first 3D print that we created was on a Stratasys machine, FDM. I don't have that. Oh, actually, I do. So this is a typical FDM style 3D print. You can see the rigids there, but this is the model. Once we got to this point, I printed this out just to see if we could even get that far, and yes, indeed, we did. So I went from this stage then to prototyping onto the Form 3s that we had at Steam Factory, and this one is the large size. This one is the small size. So I could print the small size on the Form 3. We could not print the big size on the Form 3. So we decided to take the plunge and picked up a Form 3L, and that worked. That was able to print this. We were able to print that no problem. As we developed and worked through the product and refined it so that we could get to we could get the holes for the buttons, all that good stuff, we started to have some problems. So the Form 3L was working fine for us for some of the prototyping. As we started to refine the design and get closer to the actual finished product, we started to have issues with our printers. I shouldn't say we were having issues with the printers, because we ultimately resolved the problem, and it wasn't necessarily the printer. So I've got a couple of the failures here. I kept a few of them, but we had a lot of failures. One of the things that that virtual radiologist liked was to have a texture on the surface. They didn't want it to be smooth. So we actually added the texture to the CAD model, which took some significant processing power. But I don't know if that contributed to the problems or not. But these are some of the problems that we had. You can see that we yeah, that's a failure. We had other issues. For example, we had, not necessarily so major, but just enough to make it so that we couldn't use the part. And it was significant, because we would put two sets of these. There's a top and a bottom. We put two sets of these onto the printer, and and once we set the print going, to print two sets was about 40 hours. So 40 hours is 40 hours. That's 2 days, basically, almost 3 days, well, 2 days, less than 2 days, but still pretty significant. So ultimately, we got to the point where we were able to determine where the problems were coming from. And we added some, let me go get some here. So to overcome some of those problems, we added features to the model inside. These features, adding a little more material to the inside, as well as making the wall thickness, increasing the wall thickness, adding some ribs and so on. That took care of the problem. From that point on, we were able to basically set the print files up, hit file and print, come in 40 hours later, and our prints were done, and they printed successfully. So we were very happy about that. So happy, in fact, that I picked up 2 more Form 3Ls. We got that. We got those working. We still continued to have issues occasionally from time to time, but our uptime probably went up to about, our success rate probably went up to about 75%. After that to 80, which was 75 to maybe even 85, and that's from probably, unfortunately, 65% success rate. And once we were able to do that, we were able to finally start producing devices for these guys, and that was fortunate because they were right at the end of their stock of the original ones. So it was really fortunate that we were able to help these guys out. But still, we were still playing catch up just because the Form 3Ls were so slow. Even though we had 3 of them and we were constantly getting parts out of the machines, it was still taking a long time to get things out, and we were able to do it, but it was challenging. And then the Form 4 comes onto the scene, and I'll talk about that in a little bit. First, what I want to do is actually, you know what? No, we'll go ahead and just start talking about the Form 4 because that made a huge difference in everything that came next. So Form 4 came out. We purchased 2 of those. We could print the large size on the Form 4. We could print 1 set of the large size, so it would be the shell and the base. We could print these 2 on the Form 4, and they came out beautiful. They were stunning. I'm kind of speechless because we have never had a failure of these parts on the Form 4. Not to mention the fact that to print this on the Form 4 is about 2 hours. Pretty amazing. Maybe 3 hours. But we still wanted to really get our throughput going, and we picked up 2 Form 4Ls, and that hit it out of the park. That blew us away because, as I mentioned earlier, we were printing these guys, 1 set of this plus the base, and it was taking about 40 hours on the Form 3Ls, and that was for 2 sets, so we could do 2 sets on the 3L of that assembly. On the 4L, that went down to 9 hours and 3 sets. So we were able to put 3 sets of this, 9 hours on the Form 4. Mind-boggling, just unbelievable. So as a result, our customers' goal was to build up their inventory so that they had sort of a safety stock of about 200 units. We were able to get them up to 200 units in, I would say, 3 months. And we probably could have done it faster, but the machines print and they're done, but nobody's here. And if we had someone to load the machine again and start printing again, then we could have probably done it, had it in a matter of weeks. So it was pretty amazing. So that's how it is with the Form 4, and right now we're getting another 2 more Form 4s. I'll talk a little more about where Steam Factory is headed, but first what I want to do is talk about the design. And let's kind of dive into that. Okay, so the original design of the this device is called the grip, the VRAD grip. This original design, I did manage to find where it came from. This was a company in Australia made this as a game controller. It was made in China somewhere. It wasn't very popular at the time, and this was probably around the early 2000s, I believe. It wasn't very popular because there were other game controllers, but basically it had the same number of buttons as you would find on like a Sony game controller, and on the Sony game controller. So somebody had designed this, and it's injection molded, You can maybe see that here. And if you're familiar with injection molding, you know a shape like this is going to be a challenge, especially since you're going to have, if you look here, we've got these openings and they're not straight, right? This is a very organic shape. These openings are going to be a challenge. And then on top of that, you have to have the buttons somehow mounted inside here. And the mount inside here has to be strong enough to hold these in. There are these gussets in here with some mounting bosses, and then in addition to this device, this piece and this piece, there were 1, 2, 3, 4, 5, 6 more. There were 6 more components, plastic components, that were also injection molded to hold the buttons in. Now they have these screw-in bosses here, but they were really challenged with how to get these the buttons to be secured here. The way they did it was with just massive amounts of hot glue. So they had basically hot glued this side of the buttons PCBs to the inside of the housing. There's a controller board inside here, as well as a little LED that was underneath this. Then this piece has these long, really flimsy gussets here. These were designed to be behind the PCBs to sort of support those and keep them in place. So then this goes together like this. There's some screws that hold it in, and that's how this would work. The buttons would be here, of course, and over time that hot glue would wear out, and the pushing on the buttons would push the buttons down inside, and then the thing would be useless. In addition to that, I guess the company thought it would be nice to give it a texture, kind of a rubber texture. This is just rubber spray paint. And it what users found over time is that it would become sticky, and then eventually the rubber paint would wear off, and then it would just be really gross to use these things. And that's one reason why what we did was add a texture. Now, keep that in mind. So that was the injection molded component. You know, you have to take into account all the things that you need to think of when you do injection molded parts. There's draft, there's wall thickness, all of that. The wall thickness is very thin here. Not that that's really a problem. This is probably an ABS or PC ABS. And but you've got these thin features down inside here. You've got these bosses and so on. A lot of restrictions to what you can do with that in order to make sure you don't get any print through or sink or any of that kind of stuff on the surface. That's probably one of the reasons why they put a coating on here. So when we approached this design, I wanted to get rid of the little brackets for holding the PCB, and because we were going to 3D print this, we didn't have to worry about direction of pull or draft or wall thicknesses to some extent. We just designed it to work. I'll throw up a video here. I have a little video that I'll add to this that shows how this goes together. But just know that it's only one piece. Well, it's 2 pieces because we've got a bottom here. Plus, you can see that the wall thickness is really beefy. This is really, really comfortable to use. Way more comfortable than this. In addition, I think I can get this on camera here. We have texture. Now, don't worry about those scratches. We can actually get rid of those. You might be able to see that there's a texture. There's like a knurling texture down here as well. That texture is in the model. These printers are so good that they can print that texture. And this isn't even at the highest resolution. So, VRAD was extremely happy with the success that we have with this. The coolest part of it, though, is that over time we've been able to edit these files, to make changes to them in the course of production. We've had improvements like adding little bosses here. We improved the little window here. We actually got rid of the window, so it's no longer an extra part, but we can print the resin thin enough that light will actually pass through it. I don't know if we can see that or not, but here, let's see. I don't know if you can see through there, but it's really thin, and when you put a light on it, it'll actually shine. It'll light this up. So we've got a little blue light in there, and we're working on a new reflector design to help disperse that light. But this is an end-use part. This goes out in the field. Once everything's assembled, just like any other product, put it all together, put it in a box, ship it to the customer, and then use it. Is it as durable as an injection molded part? Well, I could probably drop this on the floor and it probably won't break. I don't know if I'd want to do that with this. However, don't drop it on the floor. Okay, let's make that first rule. But if you do drop it on the floor, it takes less than an hour to print a new one, if we need to print one of these. And it takes about 15 minutes to assemble it. So if something like that happens, and it hasn't yet, we have not had any incidents of anyone asking for a replacement from one they've dropped, we can do it, right? We can turn that around in no time. That's the beauty of doing this kind of manufacturing. It's sort of like just-in-time manufacturing on steroids, if you remember what that was like back in the day. That was kind of a hot topic, right? And the great thing is that we can meet their production requirements, and it doesn't matter. We can scale up or down, and the cost is the same. For the short run stuff, that's great. If they want larger volumes, by larger volumes, I mean if they want 120 in a month, that's not a problem. There's never going to be a time where they will need more than that, and that's something I want to stress about manufacturing with additive equipment, in particular Formlabs, because you cannot match the performance that you can with the Form 4s, the Form 4 and the Form 4L. Just phenomenal. It's people use the word game changer, use the phrase game changer a lot. It's a paradigm shift, game changer, breakthrough, whatever you want to call it. It's going to be tough to have another breakthrough like that anytime soon. So we're taking advantage of it. As a result of our success with this product, we have other products that we're doing, maybe not at the volumes. We're certainly happy to do volumes like that, and we'll be looking for more of those kinds of projects. This is in the sweet spot of 3D printing with Formlabs, and we just love how it's all turned out. We have some ideas for changes that we want to put in this. We might possibly replace the buttons here with a little hat switch instead. Lots of great things, but the cool thing about that is all of that is possible, and to do it is not anything major. We can make that change and just slide it into our production run. There isn't any other consideration or anything else that we need to be worried about with that. These devices are FCC compliant. We did get all of that tested out. It's not any kind of a medical device, so it doesn't have to conform to any ISO regulations, no 60601 requirements, any of that kind of stuff. So really awesome device. Very happy with how Formlabs has made this possible. The Form 4, hands down, just made this absolutely contributed to the success of this product, and we're really, really happy to be working with Formlabs equipment, and really looking forward to what comes next. So, all right, so that is a summary of Steam Factory, highlighting one particular success story. We have several others, but that's our favorite one. That's our showcase. Absolutely. Look us up on media. We're going to be expanding more and more. Stay tuned at steam-factory.com. On May 1st of this year, we are going to have a grand opening for our brick and mortar Steam Factory store located near the University of Minnesota campus. I will be sending out notifications to all of my customers, friends and family, everybody. Really hope to see you there. It's going to be a blowout. We're expecting it to be a lot of fun. Stay tuned to the website. We're constantly making changes there to update information. All right, so that's it. I'm going to sign off for now. Hope you enjoyed that little mini documentary, I guess, on Steam Factory and a success story in additive. Absolutely a success story. Don't let anyone tell you it can't be done. We're proof that it can, and it can be done very successfully. All right, so I'm Rick Bedeau signing off, and hope to see you guys out there 3D printing.